Welcome back everyone to our fourth and last video presenting the material in chapter 2 that we're going to deal with this week. So last time we dealt with three-dimensional moments in three dimensions, the most general case. So a couple of comments. So we often want to simplify a system that has many forces or has forces at different angles into an equivalent system. So, for example, you could have, and we're going to do a problem like this at some point, but if you have this bracket, this J-shaped bracket, you have a force at an angle being exerted on it at that tip. Well, you know that this is exerting a force that's being transferred up to the surface, but you know this is also rotating it. So this is equivalent. That's that surface up there, to a force at this point. As far as the bracket's concerned at this point, this is an equivalent situation. With O being that origin there. Right, so depending on the problem, one or the other might be more important or more useful, helpful in solving the problem. But just remember that you can do that. And in general, it's often useful if you have just the blob, you know, any generalized form of something that has a bunch of forces coming off it. Okay, these can all be combined into a resultant force. The resultant, usually called R, is just the sum of all the forces acting on the body. And again, sometimes this is a lot easier to deal with than all the separate ones. Sometimes it's helpful to deal with the separate ones. Sometimes it just depends on the problem. But this isn't just for forces. You can have that body, and you can have a bunch of little moments about different points. All right, and you can do the same thing. You can have a total moment which equals a sum of all those little moments, right? Giving you the big picture of what's going on. So, finding resultants, or sometimes resolving resultants into their components, is an important part of problem solving in statics. So, this M total actually is probably more commonly called a resultant moment. So you'll probably see that more common than the TOT for total. All right, so since we're taking some time to look at the summing of moments and forces, there's one other particular situation that comes up frequently that has a special name. They're called couples. And I don't know if you remember the big old steering wheels on buses, or maybe you've seen a big old steering wheel on a boat. All right, so we're gonna pretend this is a circle. All right, and there's a center to the circle. This is the steering wheel to a boat. All right, each of these distances is d. Don't confuse that with diameter. Apologize for the nomenclature weirdness. But the reason they're d is because it's consistent with our most recent nomenclature in that they are the perpendicular distance from the point of interest to the applied force. So d, the d's are moment arms from the point of interest to the force. Right? So if you think of this as a steering wheel, okay, each hand is applying a force to move the wheel. So a large wheel provides a large moment arm and provides more torque. So if we're to simplify this down, what you have is force here, and a force here, and 2d separating them. Okay, so you can think of this two ways. You can think of it as here, F. Over here, you have a moment that is F at D, plus you have a moment that is F dot D. So you have 2F times D. Okay, so when you have this situation where you have two forces that are equidistant from some point of interest, two equal forces that are equidistant from a point of interest, you have a couple. All right, so a couple is made up of two equal and opposite forces separated by a distance. Okay? So, the magnitude of a couple is the magnitude of the force multiplied by the distance between them. So in our case above, up here, force times the distance between them, which is 2d. Your book on page 51 I'm not going to do all of these because they do a much better job of drawing them, but they're definitely worth looking at. Shows a bunch of couples. All right, so for example, you have a force applied. It's minus F. Here's plus F. And then you have the distance between them. Okay, just one more example here. So if we apply F, that's not so good. Right there. If we apply F here, minus F here, and the distance between them is D, and there's several possibilities with this. They're all equivalent. They all produce the equivalent situation. If we were to draw this out, they all produce this moment. Right, all of them are doing this. All right, so take a look at that. They have some decent drawings of it in there. It's worth a look. So that is it for our lecture material. We'll see how we do on Wednesday with examples and how you're getting on. If you feel like you need a couple more examples to look at, I can always video a couple more examples and post those. So with that, have a good day, and we will see you soon.